Okay, absolute configuration at carbon stereocenters. What we see is a bridge structure. Here's a nitrogen in the bridge. We have two stereocenters, 1 and 2. What you should recognize is this one here attached to the hydroxyl is not a stereocenter due to symmetry. So you always have to be looking for symmetry in molecules. So what are the R and S values for each carbon? Let's apply the CIP rules. We assign priorities 1 through 4, where number 1 is the atom with the highest atomic number attached to the stereocenter. Number 4 is the lowest. And then what we can do is redraw this out. Here's our carbon stereocenter. What we see is that nitrogen is attached with the wedge covalent bond. This means it's pointing out of the plane. In this case, it's pointing up with the bridge. And the hydrogen is in the back. What you see is the hatched lines. So we clearly know our number 1 and our number 4, nitrogen being number 1, but we have our 2 carbons here. So priorities 2 and 3 are more difficult to assess because they're each bound to carbons, which have equal priorities. So what we do is we go into overtime and we start looking at the ones that are next to it. And when we do that, what we see is that there's a CHH over here and there's an OCH over here. And then the O is higher atomic number than the C. So that means that the carbon over here is priority 2. So we've assigned our priorities 1 and 2, 3, and 4. What we do then is we go to the next set of rules where we draw an arrow from 1 to 3 over here, and we tentatively assign it in the counterclockwise position, which means it's going to be an S, and that's going to hold as long as the number 4, the smallest group, is in the back with the hatched line. And that is indeed the case. What we can conclude then is that the number 1 is going to be a stereocenter with an S configuration. And what you can do then is apply the same concepts to the second one. And what you'll determine is that the correct answer is choice D, 1S2R.